Good morning, friends. Today we will discuss about data types in C. Okay. So data type in C has been classified into primitive data type, user-defined data types, derived data types, and finally the world. Okay. So we will go through each of them. So we have already gone through, we have been using some of the data types. All that data types belong to this primitive group. So still now we have used char, int, float, double. Okay. So this much data types we have used. So we will go through that one by one. Okay, so this is the classification of data type in C: primitive, user-defined, derived, and void. Okay. In the primitive we have char, int, float, double, long double, like that. For char we have again signed and unsigned is there. And for int it is signed, unsigned, short, long. So I will discuss about what is this. And for user-defined type, we have type def and enum. And for derived data type, we have structure, union, array, pointers. And the last type is a void. Okay, we will come to this one, primitive data types. Primitive data types, first one is char. We already know char is a data type for storing a character. So what we do is that if I want to store a character, I will create a character variable A. Okay. And the format specifier I used is percentage D, percentage C. So percentage C is the format specifier I am using. For these data types, char and int, we have some modifiers are there that we commonly use. Modifiers are, these are the four modifiers: signed, unsigned. These two modifiers are used along with the character data types. Okay, unsigned. So not unsigned, it's unsigned. Unsigned, unsigned, and signed. So that's another modifier that is being used along with this character data types. So if you want to use signed character, I will write like this: signed char B. So that means B is a character variable of signed type, and unsigned char C indicate it's a character variable of type unsigned. So we will see what is the difference between signed and unsigned. Okay. So for that we will see the list of table. A table is here given below. So when we are creating a signed character, the total memory space allotted in the computer will be 1 byte. So 1 byte will be allotted. So we already seen that using the size of operator, we find out that the size of the character variable is 1 byte. So format specifier used is percentage %C. So if you are using signed char, okay, then the range 1 byte, we already know that if we allocate 1 byte, that means we have 8 bits will be there. So 8 bit total size will be 256. 256 size will be allotted for us. 2 raised to 8, 256. 2 raised to 8 bit. 8 bit is there. So our total size will be 256. So we have two options. Either we can start from 0 and ends with 255. That's one option. And or we will start from minus 127 and ends in minus 128, I think. Minus 120. We'll start from minus 128 and ends in plus 127. The size is same. So only difference is whether we are representing 256 from 0 to 255 or minus 128 to 127. So what's the difference between these two? So it's I will show you the example. If we are using a signed character, signed means the size range is between minus 128 to 127. Then totally we will have, I will show you. Okay. Totally we have 8 blocks will be there. 8 blocks will be there. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, age. And for signed character, the location that is available for storing the data will be only 7. Okay, this much portion we can store there, and this location will be used for representing the sign. It will be used to represent the sign, whether it is a positive character or a negative character. So that will be represented here. This bit will be used, only 2 raised 7 bits will be used for representing the data. Actually, the representation is like that also. The range is between minus 128 to 127. So total data we can store is 2 raised to 7 only. So what is minus? Actually, we have already discussed about the ASCII table. We saw the ASCII table. I will show you the ASCII table. ASCII table. See. Okay. So we'll take the image. So this is the ASCII table. So ASCII table is ranging from 0 to 127. So it's ranging from 0 to 127. So this much data we have to represent. Now negative symbol is there in the case of characters. Okay. But if we are using signed character, we can represent negative. Negative characters can be also stored. So that's quite confusing. But what's the use of negative characters? Negative characters is not normally used in the case of characters. The thing is that if when we are doing programming with the very light device, like very small devices, sometimes we may need to perform arithmetic operations using the characters. So then we have to represent numbers in character form. In that case, we will represent negative numbers. So in order to represent negative numbers, we will use this bit. Mostly this last bit will not be used because characters no need of being representing a sign. Sign is not useful. So with this 127 bits, we can represent the whole ASCII characters. ASCII characters we can represent. But there is one more table is there. Extended ASCII table is also there. Extended ASCII table is there. So that is starting from 127. I will show you that. It's starting from 128 to 255. So total character is from 0 to 255. Of this, normal characters are ranging from 0 to 127. That will be represented with both signed and unsigned. Okay, if you want to represent a character greater than 127, okay, then it should be converted to an unsigned. It should be converted to an unsigned character. Then only the range will be between 0 to 55. So it will be automatically converted. If it is not converted, the value will be again coming back to minus 127. So if we print, I will show you an example. Okay, so this program, actually we have the number. I'm going to create an signed character P. Okay, and I'm setting the value as 127. So it's the signed character. Its range should be between 0 to 127, minus 128 to 127. So what will happen if I increment it? P is being incremented. P plus plus. I incremented. And I am trying to print the value of P. This is signed character. So I am printing it as percentage %d itself. I want to see the ASCII character. GCC. Compiled it. We'll write it as semicolons here. I'm just running this code. So the range becomes minus 128, not 127, 128, because the value is, its range is between minus 127 to minus 128 to 127. So okay, so the if I'm printing like this using percentage C, then what happens is that actually we want to represent, so we will get a character in the extended ASCII list. Extended ASCII list have a list C. What happens is that actually we are getting minus 128, but that is not a valid character because characters are ranging from 0 to 255. So it will be converted to an unsigned character form if the range is above 128. So that's the thing. So only thing that you want to understand is that characters, we can have two options, either signed and unsigned characters are there. Mostly both are almost same, but the range is different. So range of a signed character is minus 128 to 127, and if it is an unsigned character, it will be 0 to 50. I will show you this unsigned case also. If we take unsigned and I am trying to print the value of P, it will be automatically 128. It's 120, it's not negative 120 because the range is up to 255 is there. If I am adding 255, 255 plus 1, I'm trying to add, then it will come back to 0. So it will come back to the 0 because its range is between 0 to 255. So if you are printing percentage C, it will not affect it. We will not get the right, we will not get the feel that what is happening inside that, because both for signed and unsigned we will get the answer correctly. The only thing is that in the case of unsigned character, we will have 8 bits for representing the character, but in the case of signed character, the character range, the available space for storing the data is only 2 raised to 7. So 7 bits will be allotted for the character, and the 1 bit will be used for representing the sign only. So that's the difference between signed and unsigned characters. So you can use both of them according to your requirement. Both are 1 bytes, and it is signed and unsigned. So we use this modifier. Normally, if you are thinking about characters in normal case, both are not required because we are not representing any signed character. Thing is that when we are doing some arithmetic operations with characters, we may require to store signed negative numbers there. So in that case, we can use signed characters. So that's the difference between signed and unsigned characters. So that's the first option of primitive data types. That is char belong to two types, signed and unsigned. Next comes the integer type. So we already know that when we are allocating, when we are creating an integer variable, that's normal size. Then I'm creating an integer variable. Suppose I'm creating an integer variable int p. Okay. Then I'm trying to print the value of size of p. Size of p. What I will get is size of p. What we will get is, so we will get 4 here. For my compiler, it is saying that's 4. But what we are represented here is a 16-bit processor. Then the range of normally integer will be 2 bytes. So for all integers, it will be of 2 bytes. 2 byte space will be allocated, and the format specifier uses percentage %d. Okay, so if you are using an integer data type, and one more thing I forget, if you are simply declaring a character variable, it can be either signed character or unsigned character, depends on the compiler. Okay, so now comes to the case of integer. Okay, integer we have options like we can have either, I will clear this. For integer, we use %d format specifier. Okay, so there are a variety of options are there. We can have signed int, and we have unsigned int. Suppose I am assuming that 2 byte of memory will be allocated when an integer variable is being created. Okay, 2 byte of memory is been allocated. Okay. Then how many bits I will have? For 1 byte it is 8 bits. So for 2 bytes it will be 2 raised 16. 2 raised 16 memory space will be allocated for me. Okay, that is 65535. That's value. That is 65535 is the value. Its value is 65536. That's what's the value of 2 raised 6. You can check that. So that's the maximum size it can have. Okay, so it's 65536 is the memory space we have, and we have two options are there. If you are using signed integer, so that means we have to represent signed number also. Negative, some portion will be given to the negative number, and some portion will be given to the positive. That is, half of this portion will be given to the negative number. So that is 32767 will be given for signed part, and plus 32767 will be the range. So it's half of 65365 divided by 2. So that's that value will be this one, 32768 to 32767. That's the range of a normal signed integer. So normally the signed integer is 2 bytes. Okay, and for unsigned integer it is the range is minus 32768 to plus 32767. So the bytes allocated will be 2 bytes. If I am using unsigned, then the range will start from only 0. So the range will go up to 65535. That will be the range. So total memory space will be 2 bytes itself. Only difference is that its range is from 0 to 365. Okay, so that's the difference between signed integer and unsigned integer. So only difference is that in the case of signed integer we can represent negative number. So among this 2 raised 16 blocks, only 2 raised to 15 blocks will be allocated for data, and 1 block will be allocated for the representing the sign. Sign will be the same concept will be there. Okay, so for unsigned we have the whole data. 2 raised 16 blocks will be used for representing the data. That much data we can store. So we have another option is there for integer. We have short and long modifier is also there. Short and long modifier. Okay. So if in the case of short, if I am using short int, normally the int will allocate 2 byte of memory. If I am using short int, the number of byte allocated will be only 1 byte. Okay. So here there's a small mistake. It's not short int. It's not 2. It's 1. It's actually 1 here. So we can exit. This can be modified as 1. I think. Short int. These two values can be modified as 1. So if you're using short, the range is reduced to 1. So 1 byte will be allocated for short int. Okay, we will check that. I'm using short int. So short int. Is there any size differences there? Check that. It's 2 bytes. It's been reduced. Here initially it was 4, so it's been reduced to 2 for my processor. So what we can say is that if we are using short int, the size will be reduced to half. Okay, its size will if I want to store only 1 digit number. Okay, I don't want to represent this large number, so I can use a short int. Instead of using long int, I can use a short int. Or an int is not required. 4 byte memory is not required because my data I want to store is only 1 byte, only 1 digit number. Then I can use this modifier short will be added. Either signed or unsigned option we can add with that. Okay, this is size of operator. So we'll check that. Then we have another modifier is there. Long is also there. So we'll check that also. Long means the size will be increased by double. Okay, so that's long modifier. I'm using long. It's here is showing almost same. Long is same as the but what we can say generally is that if you want to store a large number, we can have a long integer like this, long signed int, long unsigned int. So long is normally what we are representing is that long is for representing the size will be increased by 2 bytes. It depends on the processor. Some processor will not show like that. But generally what we can say is that the range will be increased by 4 bytes. So 4-byte memory. So here it is 2 bytes. So 2 raised to that much memory will be allocated. 2 raised to 32 memory block. That's this range. That you can easily calculate by finding the 2 raised to power. Okay. So that's the range of a long signed int. So this is long unsigned int. So if you are using unsigned, then the format specifier is %u. %u format specifier is used with the case of unsigned integer. Okay, so normally what we use is %d, and for if we are using %long int, I will show you that. Okay, that's why the %u come here, because the size can vary. So if it's normally the size of a function is returning an unsigned integer value. That's why it's written as %u here. So %u indicate it's a it's an unsigned integer is being returned by this function. Okay. So if you are using long int and the specifier the specifier I have to use is %ld. %ld is the format specifier I have to use. So altogether what we can say about integer is that integer format specifier is %d by default. We have signed integer and unsigned integer. Signed integer we can represent negative numbers also. In the case of unsigned integer, the negative numbers cannot be represented. These positive numbers can only be represented. Suppose we are creating an unsigned integer and we are storing an negative number. What happens that it will automatically take. It will take that by converting into an unsigned format. Okay. So so format specifier used here is %u. %u is the format specifier used in the case of unsigned integer. We have two modifiers are there. Short and long can also be added along with the signed. So what we can say is that if we are using long, short we can simply use %d itself. In the case of long, it is %ld. %ld is the format specifier used. So normally the integer is of 2 bytes. If you are using short, it can be reduced to 1 byte. Okay. If you are using long, the specifier will be the size can be set as 4 bytes. It's almost same as a double. So that much space will be allocated for this integer. So that's the primitive data type, second type. That is the our integer data type. 4 options are there: signed, unsigned, short, long. Okay. Next comes the float, double, and long double. Okay, so before that we will go through this. Each variable in C has an associated data type. Each data type requires different amount of memory and have some specific operations which can be performed over it. Okay, here the most basic data type in C, it shows a single character and require a single byte of memory in almost all compilers. A single byte of memory will be allocated for char. For integer, as the name suggests, it's an int variable is used to store the integer. Okay, this is used for int. Float, what we can say is that it's used to store decimal numbers. So that we are discussing now. There are two types of floats are there, mainly float and double. Decimal numbers are represented using float and double. Okay, so float, it is used to store decimal numbers with the floating point values, and it uses a standard, and the standard is IEEE 754 single precision. That's a standard used by float. Okay, and for representing this float number, it uses 32 bits. 32 bit will be allocated for this float memory. Okay, So 32 bits will be allocated. So 8 not 2 raised to 4. To this normal size of the float, it is that much memory will be allocated for a float. Okay. And in the case of double, it is used to store decimal number with the floating point values. It uses another. It's also used to represent decimal numbers, but its standard is different. It uses IEEE 754 double precision numbering system and uses 64-bit to represent the floating point number. Floating point numbers will be represented. So both float and a double are representing in different format. Okay, so that we have to understand. So what's the difference? So we will see that in the case of float, it is 2 raised to 4. That is, its range is between 3.4 e raised to 38 to 3.4 e raised to 38. So the format specifier used is percentage %f. Okay, percentage %f is the format specifier used. If we are using double, then we have to use its range is between minus 1.7 e 3082 plus 1.7 e 308. Its range is up to 8. Okay, so percentage LF is being used. We'll see that if I'm using a float, we'll see the size. Float of P, and see, I will check the size of P. So what it is returning. So it's returning as 4. And if I'm using it as double, then the format specifier I will get is what size I will get. So its the size has been increased by 8. So I am using long double. That's another option I can use. Long will be added with that. Long double. Then the size will be increased by 10 in some case, and we can say 16 for my processor. So these values will vary based on the number of processor. So what you can write in the exam is that I am using a 16-bit processor and this will be the range. Okay, so the format specifier I had to use is percentage capital LF is used. If you want to store a large floating point number, I have to use this long number. Now, with precision value, it's varying. Okay, so what we have written here also the same thing. Different data type also has a different range up to which they can store numbers. This range may vary from compiler to compiler. Below list of range along with the memory requirements and the format specifies on a 16-bit GCC compiler. So it's using a 16-bit compiler for processing this, and that's the range of the 16-bit compiler that we are showing here. Okay, so that's the data type. So we'll see some examples. Okay, so we'll see further examples here. Before that, we'll come to an example. Okay, we'll discuss this one. So we'll take this example. So I'm using a float number. We'll just copy this code. Okay, so what I have written here is I created a float variable, a double variable, a long double variable. Okay, so just compile this code. So there are some errors of the percentage. This codes we have to remember. And I will put this like this, percentage. So now it will work. Void main is compiling. So what's this code is? It's a float value. It's 3.14. Pi value is written. So with precision, I have written 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 decimal value is being represented here. Same I'm using in the double. with precision value. The same 16 numbers are being written. Long double I used, range has been increased 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 digits is being represented. So 3 numbers are there. So if I'm using normal float number and I'm trying to print that value, we'll just print this value. We'll do this later. I'm just going to print the value of using percentage of printf percentage of a. So you'll see the answer. You just run that. So the thing is that we are not getting 16 digits. It is 14159. After that, it is not 2. It is written as 3 because these remaining values is being rounded, and the value is being stopped there. Only that much digit can be represented. So almost 6 digits we are able to represent in the case of float. So if I want to represent, if I am trying to represent 16 digits itself, I cannot represent that. Okay. So what is this 16? What I am trying to do is that after decimal value I want 16 numbers. If I am writing like that. Now I will get the 16 numbers that will be there. So thing is that the 5992, then it has been rounding 7 for the 16 digits will be represented, but the actual content will not be represented because it cannot represent the whole number. The number will be there, but there is some differences there. This is that 16 indicates that if I want to print a large number, the size we can specify. Okay. Before this also I can specify, if I am specifying it as 2. So but there's no 2 digit here. So suppose we this much digit is there. So we'll get that value. Okay. So this 2 indicates that 2 is not working. Okay. This 2 indicates, this 16 indicates that how many digits it will print. Normally it is not printing 16 digits. It is only printing up to 6 digits. The remaining digits has been rounded off. But if you want 16 digits, we can write like this. But still, we are not getting the actual value because rounding happens. The same thing if I am trying to do with double, we'll see the output. So here the value is, I will add a slash n. Here. We run it again. So what's the value I'm getting is, it's 92. Then it's almost getting 65. 65 is there, 35 is there, 89 is there, 79 is there, 3, and the last digit is only modified because that's the maximum limit it can store. So so that's the use of a double. The last data I can store. If I'm using long double, if I'm using 21 here, 21 here, that much data is not available. The last bit I'm trying to print. Okay, so simply add percentage LF then only. Percentage. Simply add percentage LF. What happens is that, so the value has been again reduced. Even though the double can store that much data, normally it is saying it's 8 bytes, so this much data will be represented. Remaining data is not represented. It is there, and if you want to print, I will use that 16 here. Or 16 means indicate that the whole digit should be represented as 16 digits should be represented. Then if I run that, I will get the 16 digits, and the precision is more correct here. Okay. So if I use the double option, what I will get is that I'm just running this code. So the precision is more correct here. So we are getting the whole values. we are getting the values 14159265358979 up to 79 we are getting the value. Remaining 310 it is been rounding and the zeros is been added. Some zeros have been also added here. So if I reduce such to percentage capital F, so it's a large number that is been that's why it's a double number. It's very large. So that's the difference between float, double, and long double. So if you want to store a large decimal number with high precision value, then we can use a long double. If that's not clear, then we can simply use float. So the only thing that we want to understand is the format specifiers. So here it is capital LF, and for double it is small LF, and for float it is F only. Okay. So that is that we have to discuss today. That's data types, primitive data type in C, char, int, float, double, and long.